I'm Tyler Hieber. I'm an engineering manager here at DJ.
DJ Engineering is a company that does work that other people are unwilling to or unable to.
We mainly focus on the defense side, a lot of supporting of the warfighter. Specifically, I've worked mainly with like the A-10, B-52, and several of the other fighter craft.
Tooling was always kind of an issue for us because the capacity to move tooling through, a lot of our projects were hinging on tooling, and just the speed and efficiency of getting tooling through the shop would sometimes kind of hold a project up. A lot of our projects have really short lead times, and the tooling step was a big hurdle to overcome early on.
So to make a traditional welded style stretch form block, you'd have to make, anywhere from 4 to a dozen individual components, have them all planned, programmed, machined, fabricated, and then assembled, welded, and then match machined again. That whole process here could take a month or two.
Before the LSAM 3D printer, we had did a lot of wood mill fixtures, which is basically just taking sheets of MDF plywood or compressed plywood, gluing them all together, and we would mill those. It just takes a lot more time and a lot more effort, and just a little bit more of a pain to deal with.
This is an aft cowling assembly for the A-10 Warthog. When we made the skins for it, there's 2 inner skins, 2 outer skins that are rather complex forms. We had to make traditional metal welded tools, and that cost a lot of time, resource capability to get those developed, get all these skins made. This is a perfect example of the kind of assembly that would be greatly enhanced by the LSAM's capability. With the LSAM print capability, we could have made these significantly faster, produced tools in weeks versus months, and expedited the delivery of this project greatly from what we already did.
Our engineering director at the time was looking into options for 3D printer. They brought me involved because I do have some history with industrial printers on a smaller scale, 3-foot printers, 2-foot printers, that kind of thing.
We looked at one point at metal additive. It's too expensive, it's too long, it's not characterized near as well as large-scale additive plastics.
I was unfamiliar with LSAM at that point, and that's when we started looking at what was out there. LSAM was one of the major ones out there that could produce the sizes we need and fit the need we have.
When he brought the LSAM product in front of me, I looked at that, I'm like, oh man, this sounds really interesting. I'd like to see more about what we can do with this. And then we had gotten with your guys' team, and I think did a first concept of, I think a mill fixture for us. And we're blown away by how easy it was to produce a product in a much tighter time frame with the same kind of quality that we're used to expecting with our conventional style tooling, and even replacing some of our old wooden mill fixtures, even exceeding that quality that we had been getting out of them before.
Being a US-based company, the fact that they've offered the training fairly local to where we are, and we knew that they'd be supported. Thermwood had obviously a good name behind it, so allowed us to have some confidence in the machine.
The print volumes were very advantageous for the size of tooling we're going to be producing. We've produced some fairly large multi-piece tools that even exceed the direct limitations of the MT machine that we have.
The first project, Thermwood was with us every step of the way. In fact, we even kind of consulted on them with our overall tool design, overall print settings, all that, and they basically, we're a partner through this first project and beyond.
In recent years, we have delivered a couple rather large sub-assembly components for specifically the A-10 fighter system, which has been several years in the making. We've spent a lot of hours overhauling and figuring out rather difficult engineering to pull these components together for really at this point near seamless fit into the existing systems, which is something we're very proud of.
Working with Thermwood has always been just A1 customer service. Their experience is unmatched. They know what they're talking about. They don't just make the product, they go out there and they use the product. They know what they're talking about.
I'm just very surprised by the material itself, how much it's able to hold, obviously with the right design and right structuring, but what you can do with it is pretty awesome.
Well, really what it does is change our thinking, is what it has. At this point now, we've moved away from some of our previous types of tools in favor of the LSAM. Again, that goes for our stretch form blocks, a lot of times mill fixture, sometimes combo tools where it's going to be used as both stretch form and mill fixture. But at this point, really what it's done is it forces us to think, can this tool be printed and does it make sense to be printed? It's basically a whole other avenue. It's almost like a whole other tool production shop for us. Again, because we use it for mainly in-house tooling. So it becomes almost its own entity at that point. But for us, it's really changed our thinking. I say previously when if we have low rate, low production parts, if we're gonna make one or two, in the past we might have scabbed together a bunch of MDF or other materials, machined it and all that, but that still takes a lot of time and effort. Whereas now, in this same amount of time, we could actually print something that's gonna last, be good, it's gonna be a good tool, it's gonna be a stable tool, and we know right off the bat it's gonna work.
We've been pretty eager with just print it and we'll see if it works. If it doesn't work, we're gonna adjust it. Because it's cheap enough, we're able to just do some R&D like that.
I think when we got ours, we were really impressed with the capability to produce a smooth, consistent print. And I noticed, compared to a lot of the other designs where your guys have the copper roller wheel on the back to help smooth that bead out, really made a big difference in ultimate print quality. A lot less bulging, squishing of material as we're coming through finishing loops and moving into other sections of the print at the same time.
I've been in this industry for 25 years, and there's a large contingency of people in this industry that believe tooling, all this stuff it's metallic, it's composite. Anything in between doesn't count as a real tool, it's not reliable. And people call these plastic parts, plastic tools, but these tools have proven themselves. We've produced multiple parts off of all of these tools with no issue whatsoever, little to no degradation, and the parts are repeatable every time.
I see specifically Thermwood's large-scale additive fitting very closely into our standard design process going forward. I would not be surprised if we end up with more of these machines in the future. Don't hold me to that, but I wouldn't be surprised. They have completely upended what we can do and what is currently capable, and adding continuous capability, maybe with larger machines and other unique capabilities, could drastically improve what we're already doing.
At this point, we're going to continue to make our stretch form blocks, mill fixture, all that. But as I said before, we're getting more into composite world. I see master molds, layup tools. I foresee all these things in our future with LSAM.
If I had to describe LSAM in one word, it would be new age.
If I had to describe LSAM in one word, that would be intriguing, just because the amount that goes into those machines, the knowledge that would have had to go into the build of those machines and the process and all of that is just very intriguing to me.